All right. Great. Let's talk about gerrymandering then. I said a few words about it last time. I'm going to say a lot more words about it this time. I got a lot of pictures to look at because it is fundamentally, it's still on the general topic of voting, but the ideas about gerrymandering are really all geometric. It's all about shapes, weird shapes. Specifically, the shapes of voting districts is what gerrymandering is all about. The shapes of voting districts. The shapes matter a lot. This is something that, like I said last time, some people feel like gerrymandering is like the greatest threat to democracy in our nation today, or that gerrymandering is somehow responsible for all the problems in our society. I don't go that far with it, although I do think it is super important these days. And there are a lot of people who are kind of wising up to the importance of gerrymandering, so it is a bit of a hot topic these days. Here is a picture of Connecticut. I drew a very simple version of this picture last time. So each little region you can see here is like one of the little towns, and we are around here somewhere, Fairfield, Bridgeport, and the bold lines that you see are the borders between the United States House of Representatives districts, and there are 5 of them. This is District 1, I don't know if you care. This is District 2, 3, 4, and 5. And we are in District 5, currently represented by Mr. Jim Hines, a Democrat. And what I said at the end last time is, interestingly, about the state of Connecticut. In Connecticut, the party breakdown, you can see I actually shaded in the towns. The way that I shaded the towns is the dark ones are the towns that went Republican. This was from 2016. I haven't updated this. But this was in the 2016 election in terms of the election for president. This was Trump versus Clinton. The gray towns are the ones that went for Trump, and the white towns are the ones that went for Clinton. So this is vaguely describing if there are Democrats or Republicans in these various towns. And like I said, there are 5 total districts there, and in the state of Connecticut, we have about 65% versus 35% in terms of D's and R's. That is like per person. About 65% of the people in the state generally vote for Democrats, and 35% generally vote for Republicans. But when you look at the 5 districts here, actually all 5 of them are represented by Democrats. So all 5 districts, as of now, are D's, right? This is going to be, they're going to vote on these again in a couple weeks. But I don't follow the elections too closely, but I believe everyone basically expects all 5 to go to the Democrats again. This is typically how it goes in the state of Connecticut these days. And there's something a little weird about this, maybe something unfair depending on your point of view about this. Why is it that 35% of the people in the state are Republicans, but they don't get any representative? As far as out of 5 districts, you might, given this breakdown, you might say, oh, you should give the Republicans at least 1, right? 1 out of 5 is 20%. There's 35% of them here. In fact, this is a concept that people talk about in political science more generally. It's probably a phrase you've heard before called, I have another picture here that I want to look at, but I can get rid of that right now. There's a phrase called proportional representation. This is one of the main goals of democracy in general, proportional representation. It says, in a democracy, if, say, X% of the people support a certain party or a certain position or whatever, I'll just say support a party, then that party should be represented about X% of the time. This is the idea behind proportional representation. It's not always just about parties, but I'm saying in terms of parties here. If X% of the people support a party, then that party should be represented about X% of the time, right? So in the state of Connecticut, where 35% of the people in Connecticut are Republicans, if we had perfect proportional representation, that would mean 35% of our representatives would be Republicans. Now, given there's only 5, you can't have 35% because that's not like a it's not like a multiple of 5 or whatever. But in general, this is something that we want to happen. And it is a fact that the United States of America does not have, sometimes this proportional representation, they just write PR. USA does not have a proportional representative system. There actually isn't anything in our, if I talk specifically about representation in the Senate or the House of Representatives, there are no rules which make this happen. The idea that if X% of the people support a particular party, then they should get that many of the representatives. This is kind of a general principle that basically everybody agrees democracies should work in this way, but actually the United States doesn't have rules to make it work this way. There are other countries which have very different election systems where they basically force the representation to be proportional. You can do this by things like you would have, for instance, in the state of Connecticut, rather than divide it into 5 geographic districts, you just have everybody vote, and then you would expect, 65% of the people would be voting for Democrats and 35 would be voting for Republicans. So the Republicans would get 1 or 2 representatives, and the Democrats would get 3 or 4, depending on the proportions. In some countries, you don't even vote for individual people. It's like you vote for the party, and then the party assigns its representatives by itself. These are ways you can make it so that you get proportional representation. Anyway, what I'm saying is we don't actually do that in the United States, which is how you can have this kind of situation where, Connecticut is mostly Democratic, not all Democratic, but our representatives are all Democratic, which is a little skewed. All right. One thing that I want to point out about this in particular, check out the dark lines here. I don't know how well you can see. It looks pretty visible. The dark lines are pretty weird in terms of where they go. I would like to highlight especially, what looks especially weird to me is this one, which has this kind of very strange sort of claw-like shape or something. Very weird shape. How did they make that shape? How did they decide about that shape? When I look at this map, actually, it seems to me like, couldn't they have made a nicer shape if they just kind of like did that instead? And like, instead of this little claw sticking in and this weird thing sticking out, maybe they just kind of cut this off, give it to that one. What I'm talking about is I made a different version of this. This is just completely made up. I have another version of this same map. Look at this one. I kind of smoothed it out, right? I took away that weird, they don't want to put it on the page break. I took away that weird sort of hammerhead kind of thing, and I smoothed it out like this. What I did, actually, I was slightly careful about this. I took, I believe, 4 towns out of this one and shifted them into this one, but then I took 4 other towns out of this one and shifted them into this one. So it was sort of like an even trade. You want to make your regions to have roughly equal populations, because that's why we divide the state into 5 regions, 5 equally sized regions in terms of populations. But anyway, what I did here makes a more natural shape at this point. So I'm just going to say this is totally unscientific. I just made this up. But this version here looks, I will say, more natural in quotes, although I don't know exactly what I mean by that. But it's just like a less weird shape, right? It turns out if you do this and then rerun the elections, actually this region over here has enough Republicans in order to get their own representative as a Republican, all right? If you do it this way, this looks more natural, and this was number 5 over here, right, in that corner. This lets number 5 elect a Republican. all right? Just changing where the line goes means that now the Republicans have a majority in this area, which they didn't before, all right? The reason why in the original map, the real map, this is the real map, which I've scribbled on by now, the reason why the Democrats win every time is kind of because the Republicans are too spread out. There's no individual region which has a majority of Republicans. This breakdown, 65-35, more or less exists across all the regions, and so the Republicans can never win any of them. But if you were to rearrange the lines a little bit, actually it would make the Republicans able to win one of them, all right? So the moral of the story is moving the lines makes a big difference, right? Moving the lines makes a big difference. This, of course, is not the real map. This is just a made-up fake map like I have. The real map is the one that I showed you at the beginning. But who's to say which is better? Like, is there some reason why the lines are drawn in the first way and not this way? The answer is basically the lines are drawn by whoever is in charge when it's time to draw the lines. And whoever's in charge is going to draw the lines in a way which benefits their own party. At least that's what usually will happen unless you try to stop them, right? Moving the lines makes a big difference. And I will say usually the people drawing the lines are not neutral. Right? These lines are drawn by politicians who are trying to, at all times, trying to benefit their own party. All right. So this is a big deal. The practice of drawing lines to achieve some kind of partisan gains. This is what we call gerrymandering. Right? It's when the people in charge draw the lines in a way which makes it easier for them to win in the future. All right? Now, Connecticut is, you can look at the history of this and ask yourself, all right, Connecticut has 5 Democrats and no Republicans. Is that because some Democrats drew those lines specifically to make this happen? Actually, that seems not to be the case. In the state of Connecticut, the lines that we are using now have existed for a long time. And in the past, those same lines have led to a mixture of Democrats and Republicans. So it is not like with today's populations and just where people live in the state, it is going 5 and 0. But those lines, I don't think there's a lot of evidence that they were purposely drawn in order to make that happen, because they've been around for a long time. But there are some places in our country where the lines definitely were drawn specifically to make things happen in terms of winning the elections. All right, this is really a form of it's some kind of form of cheating the election. Because the results of the election are supposed to be based on how people actually feel. They're not supposed to be based on, can I draw some weird lines on the map? That's not a democratic thing to draw the lines, right? I want to show a few examples here of examples where people definitely have been monkeying with the lines on purpose in order to influence the election. So here is, this is a very weird word here. This word is named after an old politician, a guy named Elbridge Gerry. I'm trying to write this correctly. Elbridge Gerry, I think is how he said his name. This was the governor of Massachusetts in the year 1812. People have been doing this for a long time. And the original gerrymander was, that word was sort of invented to make fun of this guy, Elbridge Gerry. And his map that he drew is here. This is a very old map of Massachusetts. And Gerry created this district in Massachusetts, which this was one of the first and most like high-profile times that somebody created a weird-shaped district specifically in order to influence future elections. So this was in Massachusetts in 1812, and I guess somebody thought it looked like a salamander, and then they were like, "Yeah, that's a gerrymander." That was their hilarious hot take or something. That's why it's called that. Anyway, because this guy Gerry created this weird shape. It's been around for a long time. All right, here's some real examples. Let me just say, at the time, people were like, "Nah, man, you're just making some weird shape just so that you'll win." And Gerry was like, "No, that's not what I'm doing. I'm just making the shapes. You gotta make the shape somewhere. I'm just making the shapes." And this is always the problem with gerrymandering: is somebody will object and say, "Hey, you're making the shapes because you're trying to cheat." And the cheaters will say, "No, I'm just making the shapes." And there's a big issue about who actually can decide, is this a shape which is intentionally trying to cheat the election, or is this just a weird shape for some other reason? All right, so there's big issues. Oftentimes these sort of maps are often decided by courts because of course, the two parties are going to argue about it, and they get nowhere just arguing amongst themselves. And this is what we do in the United States. These things get appealed to courts. It's usually like the Supreme Courts of individual states, or sometimes the U.S. Supreme Courts. Maps are, I'll say often, not always, but often decided by courts. And this means that you end up having people having to argue to a bunch of judges why I made the shape so weird, and it's actually not because I'm trying to cheat, it's because of some other weird thing. Or other people arguing, no, that shape is definitely trying to cheat. And it's a very inexact science, right? Very hard to prove the way you're doing it. Anyway, here's some other pictures I wanted to share. The Connecticut shapes I said were weird. They're actually far less weird than in some other places. So here's the districts in the state of Maryland. Maryland is well known as a ridiculous gerrymander in favor of the Democrats. These are the districts as they exist right now. And I hope you can see the lines, the white lines. Look at all that nonsense. These are, I believe there are four districts here. You can't even tell because the lines are so ridiculous. But this is sort of well known. This is the state of Maryland, and it is gerrymandered in favor of the Democrats. In favor of, the D's. All right. What you can see is a lot of, for example, what you have in Maryland is basically Baltimore is it's a big city. A lot of Democrats live in Baltimore, and then you have a bunch of sort of more rural areas where all the Republicans live. And what they've done is they took this sort of big area here, which is mostly Republicans, and they made a little snaky part of it that stretches into Baltimore so that they can pack enough Democrats into this district in order to make it go for the Democrats. And similarly for this one and this one here, they involve lots of rural Republican areas, but because of the weird little jiggity-jaggedy bits, they are picking up pieces of Baltimore and the suburbs are more Democratic. This is generally how it works. Unfortunately, just to complicate matters, you can talk about these snaky bits are an attempt to gather more Democrats into regions which otherwise would have been more Republican. That's true. From another point of view, though, what's also true is they are an attempt to put people of color into white areas and the other way around. There is a racial angle to gerrymandering that is kind of inescapable, which is not so obvious here, although we're going to see that in some of our other pictures. I don't know if you expected to talk about race today, but get ready. Here's another one. I got some more pictures. How about this is in Texas. Texas, of course, is mostly Republican. Statewide. Let's look at the region near, so what we have here is San Antonio, Austin, and Houston, which are all decent-sized cities. Cities, just in general, cities in America tend to go more Democratic, and the countryside tends to go more Republican. This is not coincidentally, cities are where the people of color tend to live, and the countryside is where the white people tend to live. These are all totally interrelated. But anyway, actually, the region around Houston, to me, looks fairly natural, just because, like I said, around a city is where you expect the Democrats to live, and we have around Houston several Democrat districts, and then in the outlying areas, several Republican districts, which that seems reasonable to me, just knowing some basic things about cities. Check out what they did, how they played Austin and San Antonio. What you have here is Austin is basically like there. And what they did is they sort of sliced it up like this. Whoa, sorry. They kind of sliced it up vaguely like that, but with very crooked lines. And they put like a tiny wedge of Austin, and they put it in the same district with this huge region up here, right? What they're doing is, let me get rid of my scribbles here. They are carving up the city of Austin into, I don't know, 4 or 5 little districts, which are then tied into these huge outlying areas over here, full of, farms and whatever. This is an effort to take the area of Austin, which has a lot of Democratic voters, and split them up into these and sort of tie them into these large areas out here. All right? Unlike in Houston, where they basically have the city districts and the suburban districts. In this area, they carved up the city and combined it with the suburban districts so that the Democrats could not get majorities in most of these districts. Now, they did have one district which the Democrats are able to win, but check out what this one does. It has this tiny little thing, and actually that captures some of San Antonio. This is all the same district. So they carved up these two cities in a way which makes only one Democratic district between the both of them. And all the other Democrats who live in these two cities have been like assimilated into these large districts of Republicans. All right, this is a classic kind of tactic. This is sometimes called packing and cracking. They packed the Democrats into this district, and then all the remaining Democrats, they cracked them up into these other ones and sort of diluted their votes by putting them in the same districts with a bunch of Republicans. All right, this is the state of Texas. And then I want to look at Houston too. Like I said, I actually think these lines in Houston, they look, I don't know anything about Houston really, but from this point of view, it seems a little more natural. I want to look carefully at Houston though. This, check out this shape. This one here, this is a very strange district. It's up here and then has this little narrow thing here and then it stretches around there. This is the district that is currently represented by Dan Crenshaw. I don't know if you follow politics. He's the guy with the eye patch. He's on the Fox News fairly often. He's a pretty hardcore, Trump-style Republican. It goes up here, around here, around here. Check it out. I have another map of Houston. And this has Dan Crenshaw's district outlined in black there. So this black outline is around that district that I was just talking about. The colors on the map, though, this is what I would like to bring to your attention. The colors on the map are the majority racial makeup of those various neighborhoods. And what you see here is Dan Crenshaw's district is basically picking up all the white people and stopping right at the border where the people of color live, all right? Is this unfair? Is this like racially unfair? I think if you ask Dan Crenshaw, why are you in a district that is snaking around just to pick up all the white people? I think he would say, I don't know, maybe he would say, well, I'm just trying to win the elections, right? I don't know if he would say anything, but I think from one point of view, you can just say, yeah, I made that snaky, weird thing just so that the Republicans would win. Or you could say, to me, it looks like you are making this snaky, weird thing intentionally to segregate the racial makeup of your districts. This is one of those things where, it is racially segregating the districts to draw the lines in this way. Is that wrong or not? I think there's a lot of sort of plausible deniability. The people who are drawing these maps can say, no, this got nothing to do with race. Why do you got to make everything about race all the time, right? I'm just doing this because I want to win the election or whatever. My response is, okay, but like, you are racially segregating the districts. I mean, there has to be something that's got to make you feel a certain way, right? I'm not here to tell you how to feel about this, but these are definitely big issues. That's all I'm trying to say about this. I think this is actually a really good example of what they call systemic racism in America. That this is something like we do have racially segregated voting districts. Now, is this because somebody somewhere is like, oh, I just hate people of color and I want to like be racist all the time? I'm a white power type. Is that because the person who drew these lines is a white power type, or were they just trying to win the election? I would say from an outsider's perspective, in a certain sense, it doesn't matter if these people are like racist in their hearts. If they are doing things and creating a system of racial segregation, that's a problem, right? And that's what I think this kind of thing is what people mean when they talk about systemic racism. Like, this is not necessarily people who are evil in their hearts, although they are creating a system which has real sort of racial issues about it. It's a system. It doesn't matter how people feel about this. This is a system. All right. I'm not an expert on race or systemic racism or any of that. Anybody have any feelings about this? Any thoughts? I don't want to be just me saying my own opinions. I'm trying to give you the impression that gerrymandering is a big deal, and it is it's a very fraught issue. It involves a lot of things that are, I would say, deeply important in our society. All right. I don't know. I got one more picture to show you, and then we'll talk some real mathematics here. Sorry, I'm so zoomed in. All right, one more. This is interesting too. Give me another page. Sorry, I don't know what's happening. This is a neighborhood of Chicago. Chicago is regarded as like a super Democrat place. Not coincidentally, it's where a lot of people of color live. This is one district in Chicago, which again has a ridiculous shape to it, all right? This one was, there's an interesting history for this shape right here. What you have here is there's kind of a northern piece of this shape and then a southern piece, and it's connected by this. Actually, if you look at the maps in detail, this connecting bit here is along a road. There are not even any people who live along that little strip. It goes like right down the middle of a road, and all the people on either side of the road are in different districts. This part is, there aren't even any people there. This is a totally artificial attempt to take these two regions and combine them into a single district, even though they're not next to each other. They just made up a little tiny strip there where nobody actually lives. All right. Why was this done? Actually, this was not a partisan gerrymander. The reason this shape was drawn was not to make the Democrats win this area, because the Democrats are gonna win this area anyway in Chicago. The reason, what you have here is these are two historically Latino neighborhoods. And for a long time, those two neighborhoods were not in the same district. And the people who lived there, really ideally, I think, they wanted to just like make a district like that. But it never happened that there was a district like that. What you had is two historically Latino neighborhoods. And if you put those two people together, there's a lot of people there. But in the history of the state of Illinois, there was never an elected Latino congressman. Why not? basically because these two neighborhoods were always in two different districts, and they were not able, then the sort of, it's not an issue of Democrat versus Republican, but in this case, what was identified as like the Latino voting bloc was never able to actually have enough people in the same district to elect a representative. And this is actually became a court case, and the court, I believe it was the Supreme Court of the state of Illinois, they, was it the U.S. Supreme Court? Okay, you know more than I do about this.
This is a case that we discussed in a class.
Oh, you discussed it in another class? Okay, great. So, yeah, I believe the Supreme Court actually told them, you have to make the map this way, all right? So this is an example where the map was intentionally drawn on racial lines, but in this case, it was not to dilute the votes of the people of color, this particular ethnic group, but it was an attempt to allow them to actually have enough people in the same district in order to express their opinion. So this was court ordered really to empower this minority group, right? And this has happened all the time throughout history, and it's still happening today, where sometimes gerrymandering is used specifically to disenfranchise people, that is, specifically to make certain groups count less when they vote, and sometimes gerrymandering is used to make groups count more when they vote. You can, and people can debate about which of these is just. You know, some people will say like, oh, we should be colorblind about everything. We should never consider ethnic groups or whatever. All our lines should have nothing to do with that at all. Which, I mean, I guess I understand that point of view, but we have the power to hurt or to help, and there are people who want to help. You know, it's a hot issue. That's all I'm saying. All right. Anybody have any comments about this? I'm not an expert about any of this, but I think it's interesting, and I wanted to give a little context to our mathematical discussion. All right. Great. Anyway, we got two big topics that we are going to discuss in our sort of mathematical discussion about gerrymandering. So the first will be, I'll say two big topics. The first will be how to do it. We're going to sort of imagine that we are the bad guys trying to draw the lines to rig future elections. How, if you are presented with a map of, these Democrats and these Republicans living here and there, how do they even come up with these ridiculous lines? So this is the first thing. We have to kind of learn how it's actually done. And then secondly, this is societally a more important question, how to detect it. Like I said before, these kinds of arguments always boil down to somebody says, no, that map is not fair. And then the other person says, no, you got me all wrong. I'm just drawing the lines. It's no big deal. There's nothing to see here, right? There are, though, mathematical measures that can be applied to demonstrate that this or that shape is unfair in some way. And there are different ways to do it, as usual. I'm just going to say there's different ways to do it. Several different ways that we're going to talk about how to actually detect it. This is important because, like I said, these things are often resolved by the courts, the Supreme Court of the state or the United States. And if you want to convince, John Roberts, Chief Justice of the Supreme Court, that something or other is an unnatural shape to use, you have to have some kind of way to prove it or something like that. Some kind of way to detect and measure partisan gerrymander. So this is what we're going to talk about. We're going to focus on the first one for today. How to do it. If I give you a map, can you actually draw the weird lines in order to make the outcome in a certain way? That's what I want to talk about first. So I have a very simple, most of the examples we're going to do are very kind of mathematically simplified, just so that we can do them easily. I got handouts. I got 3 handouts for today. Can you believe it? This is a big day. plus the homework. So what I am handing out right now is an abstract version of a map. You have to imagine this is a map of different people living in different towns or whatever. It is abstracted. Everything is just like rectangles, dots and lines. Everybody got one? All right. What you see here, and I have one of these too. What you see here is, I believe, 50 total boxes. And 20 of them are dark, 30 of them are light. I'm going to call them D's and L's. You have many copies of this because we're going to be drawing sort of lines on top of the diagram. So I gave you a bunch of different copies of it. All right. Let's imagine that each of these little dots represents like a different town or a different person or something. And the darks and the lights are their political parties. So they're Democrats or Republicans or whatever, all right? So we got 20 Ds and 30 Ls, all right? And I would like to divide them into districts. Let's say, let's make 5 districts of 10 people each, all right? The districts have to have the same size. This is true in the real world. You always make your districts to have roughly equal populations. In the real world, they're never exactly equal, but roughly equal. All right, so I'm going to try to divide this into 5 districts of 10 people each, and then ask ourselves, what is the results if each of those districts had an election? So, for example, here I'm just going to make something up. How about I put all of these ones together, and maybe I put all of these ones together also. And then maybe I put, how about these guys? That's 8, 9, 10, like that. I'm making sure to put 10 boxes in each district. And then I'm going to do one like this. There's 10 there and 10 down here. All right, those are my 5 districts. I made 5 districts of 10 people each. Maybe I'll give them numbers. Let's say this is District 1, 2 is here, 3 is here, 4 is here, and 5 is here. All right, so if we draw the lines in this way, of course there are many different ways I could have done it, but if I do it this way, then how are the representatives going to be elected when we run the election? All right, you can just count up per district. Who's going to win in each district? Move this down a little bit. So now the results. In district number 1, what I have when I count them up, just count up the boxes here. I have 4 darks and 6 lights. All right, so this is 4 dark, 6 light. So the L's win district 1, right? I hope everyone sees how I'm doing this because there's 6 L's and 4 darks. All right, district number 2 is actually the same arrangement, right? 4 darks, 6 lights, and so the L's win in district number 2. All right. Number 3 has 2 and 8, it looks like. 2 dark, 8 light, and so the L's win here. Number 4 is all light. The L's win that one. This is 0 darks, 10's light. The L's win here. And then number 5 is all darks. So this is 10 darks, 0 lights, and the D's win. All right. And so the overall result here is L gets 4, D's gets 1. All right. You can imagine these are like the districts in the state of Connecticut or something. All right. 4 of them are won by the L's, and one is won by the D's. All right. That is this way of drawing the lines. I would like to think about, can we draw the lines differently to get a different result? Is it possible to move these lines a little bit somehow and to make the results come out instead of 4 and 1, the final result to be maybe 3 and 2? Or could it be 5 and 0? Something like that. That's what I want to try and do. Anybody have maybe a different strategy you could use to draw the districts that would make a different outcome? Yeah.
If you make them all like 1 and 2, then you can get a 5 to 0.
Yeah, right. If we made all the districts just straight sort of horizontal like this, then I think what's going to happen is actually the L's will win all of them, right? For this reason. So I'm gonna draw that picture also. I got another one here. This is why I gave you so many on your paper, because we're going to do the same picture divided up in several different ways. If I divide it this way, all kind of horizontally like this. So this one, this time, I'm writing in red. L wins all of them. So this is L gets 5, D gets 0. All right. This actually, I would say, is some kind of an unfair map, just because the D's are totally diluted in every district here. There are a certain amount of the D's, but they are always just barely overruled by the L's. All right. This is what here the D's are. The lingo that people use here. I think I've said this word once already. Cracked. That is. There is actually enough D's in there for them to win a district, but their representation has been cracked up into little pieces where just a little piece of them goes in each district, and the effect is they can never win any of them. All right, this is called cracking. All right, any other way that we could divide this up to get a different outcome? So we got 4 and 1 here. We got 5 and 0 here. Does anyone see another way you could draw the districts to make maybe 3 and 2? Is that possible? Yeah, right. Here we did everything horizontally, which made 5 and 0. What if we did everything vertically, like in very skinny, tall, skinny, like your dear professor? Those kinds of districts here will have, this is, I would say, very artificial, although not terribly unfair when I think about it. Because 3 and 2 is not such a bad result, given that there are 30 light ones and 20 dark ones. 3 to 2 seems like an appropriate result, right? And in any case, here if I label them 1, 2, 3, 4, 5, so this time number 1 and 2 goes to the D. Number 3, 4, 5 goes to the L. So this arrangement gives me 3 L's and 2 D's, right? All right. Are there any other alternatives that we could make by drawing the lines? What we've seen so far is 4. Let me try and summarize. We've seen the first one was 4L 1D, right? The second one was 5L 0D, and the one we just did was 3L 2D. Is it possible to do, can we do 2L 3D, right? That would be, we haven't seen that here. Is this possible to arrange them in that way? This would actually be a very strange result, given that overall there are more L's than D's. But can you make it so that the D's actually win more than the L's? That seems backwards, although, I don't know. Are you sure that's impossible? This is what I want to try and think about here. How to tell if this is possible. Really what you need to think about is how many D voters, I'm thinking of the individual squares are voters. How many D voters are required to win 3 D districts? How many, are there even enough D's on the whole picture in order to win 3 districts? Can anyone say how many do you need to win each individual district?
6.
You need 6, right. If you have 5, then it would be 5 and 5 is a tie. Remember, that's because each district has 10. So this is important to think in these terms. So I'm going to write this down specifically, although this is all fairly commonsensical, but this is the way you want to think about it. Each district is 10. So the threshold, this is an important thing to hold in your mind. The threshold to win is 6, right? If you get 5, that's a tie, which is not good enough for what we're talking about. The threshold to win is 6. And so I can say here, for D to win 3 districts, we'll need at least 3 times 6, which is 18 D voters. Right? In theory, that means actually, in theory, it is possible because there are 20 D voters. And I said in order for them to win 3 districts, actually they only need 18. So this means that it should be possible. So the overall split of 3D to 2L should be possible. I will say since the D's actually have 20 voters, right? Only 18 are necessary to win 3 districts. So, I believe it is possible, at least like mathematically. Now, geometrically speaking is a different question. Can you actually figure out how to draw weird shapes that make that happen? But I think we can do it. Let's look at the picture again. So, I want to make D's win 3. L's get 2, all right? My strategy is I'm going to build 3 districts so that the D's win, and then I'll just give the rest to the L's. So I try to build 3 districts where the D's just barely win. I say just barely because actually they don't have a lot of voters to spare, right? They need 18. There's 2 left over, so you can't put more than is necessary into these districts. Just barely. Build 3 districts where the D's just barely win. That means I'm going to use 6 dark squares in those districts. So maybe I will take just the 6 in the upper left corner, and then just to make it a whole district, I'll add in 4 white ones. All right? So there's one district that the D's will win. I picked up 6 of the darks, and I had to add in 4 light ones just to make it a full district of 10. All right? And then I'm going to do the same thing again. Another 6 here, and then you can just more or less at random pick up 4 additional white ones. Maybe I'll take those ones. All right? And then I do it again. All right? I think it's going to work, right? I'll take 6 plus 4 extra, like that. And here I have a D, and a D. So the D's are going to win those 3. And what do I do for the other 2? It doesn't matter. You just divide up the rest, what's left over, into districts however you like. They have to have 10 each, so I'll take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that weird snaky thing, this is going to be a L, and then this weird shape up here is going to be a L. All right? You have to be a little bit careful to make this work out, but you can usually make it work out if you want to. You will see it's not a coincidence. When you are building the districts in very specific ways, you end up creating a bunch of weird snaky shapes. And this is what happens in the real world. That's why gerrymandering in the real world results in weird snaky shapes. It's because somebody somewhere was trying to play some games to make the districts be a very specific way, and then they had to make weirdo snaky shapes for the other districts. All right? Great. What about, okay, so this was, we get 3D2L districts, right? Along the same general question of what is possible, and then can we actually draw the pictures to make it happen? Let's see if we can go farther with this. Can we get 4 D's and 1 L? Is it possible for the dark ones to win 4? Maybe you have a thought about that? Yeah. No, why not?
Because they just don't have enough voters.
Yeah, there just are not enough Ds to get to 4 districts. All right, so the answer to this question is no. That's because, remember, each district needs 6 to win, right? So to win 4 Ds, we need at least 6 times 4, which is 24 D votes, and there aren't that many, right? There's only 20 of the D voters, and so that's why 4 Ds and 1 L is not possible. All right, so 4D and 1L is impossible. And the only other alternative that we haven't discussed is what about, I mean, this in theory you could think about, can you get 5 Ds and 0 Ls? The answer is no, for the same reasons. They don't have enough to even get 4 districts. They definitely don't have enough to get to 5 districts. So this is also impossible. All right. Anybody got any thoughts about this? This is a standard kind of, so typical homework question about this would be, I show you a picture, you know, like that, and I say, first of all, tell me which outcomes are possible, and then draw me pictures which make those outcomes happen. So in this case, my answer is, the possible outcomes are, you could get 0 Ds and 5 Ls, or you could get 1 D and 4 Ls, or you could get 2 Ds and 3 Ls. It's hard to say this out loud. Or you could get 3 Ds and 2 Ls. Those are the only possible ones. It's impossible to do these two. And then I drew a picture of each of the possible ones. All right? Yes?
Is it also considered gerrymandering if, like, the side that already has the most votes is, like, influenced higher? Like, for the ones that we have where it's always 4 darks and 6 lights, is that considered gerrymandering because the most of them are on one side?
Yeah, you could ask yourself, like, in all of these examples, are these really, like, unfair districts, or are they just ordinary districts? And this is a very hard question to answer, because, like, for example, from a strictly, like, from a geometric point of view, this one looks very fair because they're nice ordinary shapes. But actually, I would say this is maybe like one of the least fair in terms of the voters here, because this is specifically diluting the dark ones every time. So it's always a controversial matter to say, like, does this map count as cheating? The answer is, who knows? It sort of depends who you ask. If you ask the person who drew the map, they're always going to say no. But you ask the people who are disenfranchised because of it, they will say yes. Like I said, we are, next week we're going to talk about specific ways to measure if it's fair or not. So that's something to think about. Okay, great. I got one for you all to try on another piece of paper here. So this one, your job will be the same. I want you to try to, first of all, figure out which outcomes are possible, and then draw the lines in a way which makes each of the different possible outcomes actually happen. Yeah. These are still just squares in a grid. If you can do it on squares in a grid, you can do it in weird shapes too. So this one, I have to tell you about the scenario here. Okay, this time we have here, if you count them up, you will figure it out, but I'm going to tell you. Turn your paper so that it's facing that way. It's not possible to tell if it's upside down or not. But here we have 64 squares, and there's equal number. 32 of them are dark. 32 of them are light, and I want four districts of 16 each. All right. So Your job is, first of all, figure out which outcomes are possible. I will list down, just like in theory, the possible ways this could go. You could get 0 dark, 4 light, or you could get 1 dark, 3 light, or you could get 2 dark, 2 light. Or you could get 3 darks and 1 light, or you could get 4 darks and 0 lights. All right, the question is, which are possible? These are really 2 separate questions. Which are possible, you figure out just by how many votes would you need in order to get these districts, and then do you actually have enough people to make that happen? And then draw districts for the possible ones. All right, I'll give you some time to think about it. We got some time. Talk to your friends if you like. When you're deciding which are possible, you should decide, first of all, how many do you need to win each district? And then, do you actually have enough to make it? Okay.
So it has 16 in each district.
Mm-hmm. Yep. Yeah, I said I want 4 districts, 16 each. Get anywhere? Which one's possible? Think about if each district has 16 in it, how many votes do you need to win? 9 per district. Yeah. So, for instance, like the first alternative, is it possible for the L's to win all 4 of them? How many votes you would need? You need 9 to lose each.
Yeah.
Right. That's 36.
That's not possible.
That's not possible. But the next one, I think is possible. Is 27. That one should be possible. Get anywhere?
Yeah, I just have to redo this because I did the whole vertical, so then it was tied.
They were ties, yeah. All right. Decide which ones are possible. Yeah. Great. This one okay?
Yeah, how did a tie? It just doesn't count for anything.
Yeah. So don't do ties. You decide where the dark lines goes. So that one is we got ties here. Just your lines. It's not a tie. All right. Did you decide which are possible? This one has. So we gotta look at what. They're totally separate. Figure out which ones are possible, it's just, you can do just by looking. Okay, think about this, how many of those do you want to be? So is it possible, for instance, for the ones to win all
So this
four?
is all impossible, as we can see this out.
No.
So we'll see if it can be done.
Right.
If you just see how many boxes
So
you
that's
win,
impossible,
or
but it
the
should,
time.
like actually, this should be possible.
If the number is bigger, then we have
Three times nine, which is 27. Yeah, you think about how many.
So if this is bigger than this number,
Each district.
then you can't do it. So you should not.
You need that one, right? Because that's, yeah, so, it's like, for instance, is this possible? The lights to win all four means, at least 9 each, 4 times. That's not possible, just 4 times 9 is 36, which is 2 times. Yeah. But is this one possible? Which I think this one is possible, it's 3 times 9. That should be possible to do.
Oh, wait, so this is applying for, this is like a different thing for all four, so
Yeah, you have to think through, like, is this one possible, is this one possible?
is this impossible for all 4 districts?
You get that.
Oh,
Because, okay.
Oh, just can't,
This-
whatever
this-
number you just can't be bigger than.
Alright.
So for these,
Yes, good.
So now we can do this.
Now you got it.
is that a 10?
Yes.
Or no,
Oh,
that's one.
the-
No, you're right. You don't multiply for that, that's the one.
Yeah, this is a big number.
Oh, you just do a bigger number?
That's right. Cause we know we can make things possible.
Yep.
Three times nine is what? 7.
Alright.
Is it possible?
Yeah.
Doing okay?
Yeah. Just like, what is the minimum number?
Yes.
Oh, okay.
And so we have to.
Yeah.
We need 9 lights in 3 districts, 9 lights in 2 districts. I'm a little confused on this one. Are there 2 possibilities? Like, would it be a tie? I'm not sure.
So what this means is, this is not possible because they're not 36.
Right.
This one, it is possible because it's actually 32, which is in
Right.
here you use at least 18 of each, but that is possible.
So it would just be an even tie.
Not really, like, in order to achieve this, you need 18.
And then
Oh,
sometimes
but there's actually not one.
carry on, you just have to draw the line, so you just need.
Okay. Yeah, at this point, all you can say is these 3 in the middle are possible,
Yeah.
these 2 are not possible.
Okay.
And then try to draw them.
Okay.
You all right?
Kevin. So we're gonna need a diesel box.
Okay?
Like this red and this one.
All right? Did you decide which are possible?
No, I'm not, I mean, I just think it's possible. I just got it from my. So for this one, for 1, do you want it 3 items?
I assume it's
Just
16
Yeah, yeah.
each,
Nine to one.
and 9 to 1.
So we just go 1, 2, 3.
Yeah, so actually that's
1,
why
2, 3, 4,
this
5,
is
6.
It's like for,
We have 9.
like each
And
question,
then we need,
like
16.
and what's
just
an
6.
example, and then 2, like number of districts.
And then in this box.
I will tell you.
the diesel one.
So this one is.
Doing all right? Okay.
So this box is district D was position.
Doing okay?
And now this box,
I
we just have to.
I'm getting mixed up in my lines.
Yeah, it's hard to,
There's lose and there's 1
you know,
and a half white, so it's.
Yeah.
That's why I gave you a lot of pictures.
Yeah.
All right, can we talk about these just because we got to go in a few minutes? Which ones are possible? So actually, the question which are possible, you should be able to answer without referencing the picture at all. This is just purely about the numbers. Which ones are possible? You think about the fact that each district has 16 each. So how many do I need to win in a district? You need 9 to win in each district, all right? That's because half of 16 would be 8, which is a tie. That's not good enough. We want to win. So the threshold to win in each district is 9 per district, right? This is the way you think about it to figure out which of these are possible. So, for example, is the first one possible? Is it possible to get actually 4L districts? 0D 4L requires at least, in terms of the L's, at least 9 times 4, which would be 36 L voters. And this is not possible, right? Because there's only 32 L voters. And so this is impossible. This is the way you determine what is and is not possible, is by thinking about how many voters would it actually take to get to 4 L's. That is not going to happen. And for the same reason, you cannot get 4D 0L, because there's the same number of D's as there are L's here. All right. What about the other ones? Is 1D and 3L possible? I think about the 3 L's. Can you actually, are there going to be enough in order to win 3 districts? I think the answer is yes, there are going to be enough, because you need 9. 9 times 3 is only 27, and there are 32 of them. So that one, at least in theory, should be possible. The first and the last there are impossible. These 3 are all possible. At least, like, numerically speaking, they are possible. It's another matter to actually draw the lines. That's another challenge. But anybody have any thoughts about that so far? So this part of the question is purely like numerical. You don't have to look at the picture at all. All right. Now let's actually look at the pictures and try to draw these various divisions. As I was walking around, I saw several people had some. Let's try. So the way that I like to do this is I decide first of all what I'm going for. Let's go for 3L and 1D. All right. My strategy in drawing this is actually I'm going to focus on the 1D, and I'm going to pack as many D's as possible into here. My goal is I'm going to let D's win this one, but I'm going to shove as many D's as I can in there so that there's just not enough left over for them to win any of the other ones. This is the idea. This is what they call packing in the real world. They do this all the time. You pack all of your enemies into one district. You let them have one, but then you're going to win all the other ones. That's the idea. So I'm going to pack as many D's as possible into one district. Now, geometrically speaking, I might not be able to get like 16 D's all in the same district, but I could get a lot, right? How about maybe I will take these. There's 8 here, 9, 10, 11, 12, 13, 14. I can't let those white guys out. How about I'm going to try to get, I said this is 10. And then maybe I will grab some of these ones also. 11, 12, 13, 14. Ooh. 15. I think that's 16. I'm sure that you didn't draw it in exactly the same way I did, and that's fine. But this is, I believe, 16. You have to make sure I actually have 16 dots in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, 16. Give me one more dark. I'm trying to put as many darks as I can in here. That's because I want the D's to win this district, and I want the L's to win everywhere else. So I put as many D's as I can in there, so that hopefully just however I divide it up, the L's are going to win all the other ones, just because there aren't a lot of D's left on the map at all. All right? This is my strategy. Pack as many D's as possible into the one district. And then I should be able to just divide it up more or less how I want. otherwise. So if I take these 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, maybe those ones as another district. Just to make sure that the L's win, do the L's have at least 9 in here? They go 1, 2, 3, 4, 5, 6, 7, 8, 9, actually 10, 11. So the L's win this one, all right? And I got to divide the rest into 2 parts, and it probably doesn't really matter where I do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'll do it there. And the L's win there, and L's win there, all right? This is these problems are a little annoying for me to grade because likely you will all draw a different answer and I have to sit there and count up, do the L's actually win this one and this one? But hopefully I don't expect anyone drew this exact same thing that I did, but hopefully you do something like that. Any questions about that? We got a couple minutes. This is not the whole thing. You should have drawn me a diagram for each of the possible ones. So that was the 3L to 1D. Let's do 2 and 2, and I think that'll do it just for time. But how about 2 L's and 2 D's? All right. This one is actually the most kind of natural division, just because overall there is an equal number of L's and D's. So for this one, I'm gonna just kind of divide into 4 pieces in some ordinary looking way, and hopefully it'll all just work out. That's usually how I would do this. Anybody have a very easily describable strategy for dividing this into 4 regions that makes it an even split? I was walking around, I saw some.
The first 2 columns are vertically together.
Okay. There and there. And then can I do like this maybe? Did anyone try that? I don't know. Is this going to work? So I will just count out who wins each. Here I have, I'll count the D's. I have 6, 7, 8, 9. So the D's have at least 9 here, so the D's win that one. Here it looks like 1, 2, 3, 4, 5, 6, 7 darks. That's not enough for the D's to win, so the L's must win that one. Here I have 1, 2, 3, 4, 5, 6 lights, which means the darks win this one. Remember, you need, if you don't get 9, you're going to lose, right? And over here, the D's lose, so the L's win. So that's a 2 and 2, all right? It's time to go, but the other one you would do for the other one would be 1L, 3D, do a packing again in this similar way that I did for that one. All right, like I promised, I printed out the homework so you can do it just because I know it's a pain for you all to print things.